Hello, mood maker. Okay, guys. I think let's get stuck in grade 11. Grade 11 has been crying and calling, so let's get stuck into some grade 11 exponents, guys. We are actually now going to move on to some, I think, familiar stuff. So let's look at the multiplication and division of numerical bases. So where there's multiply and divide only. Okay, and we have just multiplication and division of numerical bases only. By numerical bases, I mean number bases, not bases that are numbers. All right, so let's look at a few examples so that we can get acquainted to this. So let's say we are given a question that says simplify Okay, let me just rewrite this, guys. It's 2 to the power x minus 1. Dot means multiply. 4 to the power x. Dot brackets 3 to the power x raised to the power 2 over 16 to the power x times 6 to the power 2x minus 1. Okay. So, guys, what we see here is multiplication. 2 to the power x minus 1, that's an exponent, times 4 to the power x. Dot means multiply, brackets 3 to the power x raised to the power 2 over 16 to the power x times 6 to the power 2x minus 1. So that's why I'm saying we're dealing with the multiplication and the division. Division, the line here means divide. Alright, so that's why I'm saying there's multiplication and division only of what? Numerical. Look at the bases, guys. 2, 4, 3, 16, 6. So the bases are numbers. Then lastly, variable exponents. X, 2x. All right, and then obviously you have variable exponents, or what we could say you have exponential expressions. So x minus 1 is an expression, x is an expression, x is an expression, and 2x minus 1 is an expression. So what do we do in questions like this, guys, when we are given the role of simplifying what is obviously a multiplication and a division of numerical bases? Multiply, dot mean multiply, division meaning the line. There's only multiplication and division. There's no addition between the bases or subtraction. What do we do? So what we do, guys, is we look at the numerical bases. So our numerical bases must be converted to prime bases. That's what we need to do. 2 is a prime base. Remember, guys, by prime we mean numbers or bases that have 2 factors, 1 and itself. So prime numbers are numbers that have only two factors. So for instance, 2 is a prime base because the factors of 2 are 1 and 2. 4 is not a prime base. 4 is a composite base. All right, so we must convert the numerical composite bases to prime bases. Okay, by a composite number or a composite base, we mean a number that has more than two factors. So for instance, 4 has how many factors? 1 goes into 4. How many times? 4 times. Besides 1, 2 also goes into 4. How many times? 2 times. So in other words, you can see that the factors of 4, there are 3 of them. The factors of 4, there are more than 2 factors of 4. So this is a composite base. 4 is a composite base, whereas 2 is a prime base. So our objective when we have multiplication and division of numerical bases with variable exponents or expressions, we need to first convert all the composite bases to prime bases. So 2 is fine. It's already a prime base. What about the number 4, guys? How do we convert 4 so that it is not a composite base but a prime base? What is 4 as a prime base? Okay, now this is where you guys come in. You are in grade 11. In grade 10 already you know how to convert. Ngutuku says 2 to the power 2. Thank you, Ngutuku. T says 2 times 2. So if you look at what you guys have said, both of you, Ngutuku says 2 squared. T says 2 times 2. Both of you are 100% correct. But what we want to do, it's better that we express that composite base in exponential form rather than write it in multiplication form. So 2 squared is the better version of the prime base than 2 times 2. Not that 2 times 2 is incorrect, but it's just that it's better to express that composite base as a exponential prime base. So what we are going to do in brackets, we are going to write 2 squared. Then remember, outside we have the exponent x. So what we do is we close the bracket, we place the exponent x that was there initially. This is how we are able to convert a composite base, which is 4, to a prime base, which is 2 squared. Now, maybe not all of us just know off the top of our heads what 4 is as a prime base. So the calculator can be helpful. How? You simply type the number, the composite number, which is 4. You press equal in your calculator. Then you press shift. Then you press fact. 4 is equal to shift fact. Your calculator will give you the prime base of 4. So let's just try this out. 4 equal, press shift, which allows you to select all the yellow options in your calculator. Then you go there to fact. There, fact. There you have it, guys. Your composite base has been converted to a prime base, which is 2 squared. So your calculator can assist you when your mind fails to get the prime base from the composite number. We move on. 3 to the power x. This 3 is already a prime number, so we are good here. So the numerator, guys, we've officially made sure that all numerical bases that are composite have been converted to prime bases. 2, that's a prime number. 2 is a prime number. 3 is a prime number. We converted 4 to 2 squared, which avails the prime number base. Now we go down to the denominator. 16 is not a prime number and 6 is not a prime number. So we now have to convert 16 to a prime base. How do we do that? Well, we are going to use our calculator because maybe our heads we don't know, but let me check in the comment section, guys. What is 16 as a prime base? Ngutuku, thank you so much. Always T, thank you so much. Yes. Ngutuku and T has said 2 to the power 4. 2 to the power 4. No, Tlochi, let's be careful. Thank you, Tlochi, for fixing your answer there. Yes, 2 to the power 4. We put that in what? In brackets. And then x on the outside. Every composite base that you convert to prime, please put in brackets. And then whatever was outside, you ensure that you don't make it disappear. The x that was there is still going to be written there. Remember, guys, when all else fails, if you don't know how to convert, 16 equal shift fact. Answer is 2 to the power 4. So your calculator will always help you when you fail to not know how to convert a composite number, a number that has more than 2 factors, to a prime base, which is a base that has 2 factors. We move on to 6. Let's convert 6 to a prime base. Very good, Ritabile. 3 times 2. Okay, Ritabile is already ahead of the game then. 3 times 2, or as Tia said, 2 times 3. Doesn't matter, guys, if we say 2 times 3 or 3 times 2, because remember, whether you say 3 times 2 or 2 times 3, both of these give us 6. 3 is a prime number, 2 is a prime number. 2 is a prime number, 3 is a prime number. So multiplication is commutative. The order in which you place the numbers doesn't matter. What matters is that we have the independent bases, which when multiplied give us 6. So in brackets, we are going to say 3 times 2. That replaces 6. Then outside, we make sure we keep the exponent 2x minus 1. So I would say that we have successfully accomplished the conversion of our composite bases to prime bases, and we have placed those converted composite bases in brackets. All right, so guys, this is step 1 of what we do when we convert composite bases, numbers that have more than 2 factors, like 16 and 6. We convert composite bases to prime bases. Right? That's what we do. Composite, for those who are coming in, Remo. A composite. Actually, let me do this. All right. For those that have brothers and sisters that are in grade 8 and 9, I'm busy cooking here, guys. I am busy cooking. Those who have brothers and sisters that are in grade 8 and 9, I'm busy cooking. Very soon, I will be doing grade 8 and 9 online lessons. So, yeah, I'm cooking here, I'm cooking. Okay, let me send you back to basics, guys. Basics. So, basics are everything, if you ask me. Basics are everything. In grade 8, right, there are what we call composite numbers. What are composite numbers? Composite numbers have more than 2 factors. That's what composite numbers are. If you are a grade 11 learner, you should be knowing your content from grades done earlier, things that you have done in maths earlier. Composite numbers have more than 2 factors. For instance, the number 6 is a composite number. Why? Because the factors of 6 are, there they are. 1, we know that 1 goes into 6 how many times? 6 times. So already we have 2 factors. We know that 2 goes into 6 how many times? 3 times. So there are 1, 2, 3, 4 factors of what? Of 6. Therefore, 6 is a composite number, because composite numbers are numbers that have more than 2 factors. Okay. On the other hand, we have what we call prime numbers. What are prime numbers? It is a number with only 2 factors, 1 and that particular number. So there's a list of numbers that I've written here that are what we call prime numbers. For instance, 2 is a prime number because the factors of 2 are what, guys? 1 and 2. 3 is a prime number because the factors of 3 are 1 and 3, 2 factors. 5 is a prime number because the factors of 5 are 1 and 5. 7 is a prime number because the factors of 7 are 1 and 7. Okay? I hope that makes sense, guys. I hope that makes sense. So it's very important for us to know the difference between a composite number and a prime number. Let's move to grade 11 now. In our exponents, when we are dealing with multiplication and division of numerical, meaning number bases that are numbers with variables as your exponents or expressions. For instance, this problem, 2 multiplied 4 to the power x multiplied over 16 to the power x times 6 to the power 2x minus 1. This here, the relationship you see here, guys, is one of multiplication and division. 2, the 4, the 3, the 16, the 6. When we are simplifying the multiplication and division of numerical bases, we need to first convert the composite bases. In other words, we look at the bases. Base 2 is a prime base. Remember, I said prime numbers are such. Base 4, not prime. This is a composite number or a composite base. We must convert this composite base to a prime base. How do we do that? I told you guys that you take the number, if you want to use your calculator, you press equal, you then press shift in your calculator, then you press fact. You will get the exponential expression of the composite base, which is 2 to the power 2. 3 is already prime. Don't have to change that. 16 is not prime, so we need to use our minds or our calculator, convert 16 to a prime base. 2 to the power 4 is the exponential expression of 16 as a prime base. 6 can be written as 3 times 2. all right, or 2 times 3. So that's what I mean, guys, by converting your composite to prime. So I hope that answers the question that people were asking about composite. Remo, I hope you are answered. Right? But when you convert from composite to prime, make sure that whatever you convert is placed inside brackets. 4 is 2 squared converted to exponential form, and you write it in brackets. Okay, 16 in brackets 2 to the power 4, 6 in brackets 3 times 2. Okay, then we continue, move further. Step number 2, we apply law 3 of exponents. You will remember that law 3 of exponents says when a base is raised to an exponent and it's multiplied with another, we simply multiply the given exponents m times n. You keep the base, you multiply the exponent. If the relationship between the bases is multiply and outside you have an exponent, you keep the respective bases, you multiply the exponents. Okay, so this here is what we mean by law number 3 of exponents. We apply that now. So you are going to go now to your brackets that you have basically have, and you apply law number 3. Then after applying law number 3, you are going to apply law number 1 and law number 2 of exponents and simplify using those 2 laws. So law 3 is first. Law number 1 then is used second. Remember, law number 1 says when you have same bases and you are multiplying, you keep the base, you add the exponents. Law number 2 says when you are dividing same bases, you keep the base, you subtract the exponents. Then we simplify, guys, all right? And we should be able to get to the answer after applying law 3, law 1, and law 2. So let's go. If you look at the first base, 2 to the power x minus 1, okay, that is your base. There's nothing you can do with that base. It is just 2 to the power x minus 1, okay, times. Here we can apply law number 3. Law 3 can be applied. So our answer there is going to be what? 2 to the power, what's 2 times x? 2 times x is equal to 2x. Okay. Then here law number 3 can also be applied. What's x times 2? That also is going to be 3 to the power 2x. Okay. Make sense, guys? You apply the exponent by multiplication, you apply it to the exponent that is there. So that's just 3 to the power 2x. Okay, please, guys, over. We can apply law number 3 here as well. That's going to be 2 to the power, what's 4 times x? 4x. We can apply law number 3 here as well, but let's be careful. There's base 3 and there's base 2. So remember here, Law number 3, 3.1. We take the base with its exponent. We multiply with what is outside for a alone. So here for 3 alone, we know that there's a 1 here that we don't see. So we say 1 times 2x, that's going to be 3 to the power 2x. Then we distribute again and say 1 times negative 1, which is going to give us negative 1. Base 3 has enjoyed the feast outside. We also give 2 a chance. Remember guys, in maths, that multiply can also be written as a dot, or multiply can also be written as a bracket. In maths, the dot, the multiplication sign, and brackets all mean multiplication. So now we are going to do the same thing with 2 to the power 1. Say 1 times 2x is going to give us 2x. Then 1 times negative 1. It's like we are distributing, guys, this 1. 1 times 2x is 2x. 1 times negative 1 is negative 1. Law number 3 has been applied successfully. Your Bluetooth has been connected successfully. So law number 3 has been applied successfully. Now we move on to the next step. We apply law number 1 and 2. Law number 1 and 2. So my goal now is to check out where are the bases, because remember, law number 1 and 2 only works for same bases. It only works for what? For same bases. So the easiest way that I like doing this particular question is in the following way, guys. Let's look at what the bases that we have are. We have base 2, base 2, base 2, and base 2. How many base 2s do we have? 1, 2, 3, 4 base 2s. Then we have how many other base 3s? 1, 2 base 3s. So what we are going to do is we are going to actually apply law number 1 and 2 for the bases that are there. On LLUTD, yes I do. You can just send me a private message, tell me the grade that you are in, and ideally, in your situation, how often do you want to be tutored and assisted? All right, so just send me a DM if you need assistance or if you need private tutoring. Okay, so guys, yes it does, Ndombi, of course it has fees. Whereas being on TikTok, you don't pay anything here. But guys, I do appreciate support. So if you can gift, please guys, if you can gift, if it's within your situation to gift, please gift the live creator. It really helps. It motivates. It's like incentive. I love gifts. I really do. So if you can, thanks. I really appreciate. Okay. And send me a private message if you need assistance. Okay, but please guys, avoid other things. So let's look at base 2 and let us apply our laws for the exponents for the bases that are there. So base 2 to the power x minus 1. If we look at the relationship between this 2 and this 2, it's one of multiplication. So what do we do, guys, when we have same bases and we are multiplying? What do we do to the exponents? We add them, right? So I'm going to take base 2, keep it as it is, and I'm going to add 2x because it is in the numerator having the same base. All right. Now, please take note of what happens next. If we go down, we have 2 to the power 4x. It is in the denominator. This is like dividing this with that. When we are dividing, guys, what happens to our exponent? The 4x in the numerator in the denominator becomes negative 4x when it is moved to the numerator. There's a sign change. So I am going to just emphasize here that there is a visible sign change whenever we collect exponents in the denominator. Make sure that the sign change is visible. So remember, I said 2 to the power x minus 1. We added this 2x because it is in the same numerator. But then we go down, we subtract 4x for this base 2. Then we go to this base 2. What's going to happen here? I said a visible sign change, because if we are going to move this whole entire thing to the numerator, it means the exponents change sign. So the 2x will be negative 2x. The 2x was positive. So now we are going to write it as negative 2x, the change of the sign. Negative 1, if we are going to change negative 1, it becomes plus 1. Take note, guys. 2x was positive, but the minute we apply the law for subtraction of exponents, we are going to write negative 2x. The sign changes. Negative 1. Also, the sign changes from negative to positive. Okay. So far, all the steps that I have indicated here are very much necessary. So we have collected the exponents for base 2. That's what we've done using law number 1 and 2. Law number 1, for multiplication of same bases, we add the exponents. Law number 2, for division, the sign of the exponent changes. 4x is now negative 4x. 2x is now negative 2x, and as well as negative 1 is now positive 1. All right, I hope we are together there. Then we collect base 3 now. Multiply 3. Then we collect the exponents for base 3. At the moment, the exponent 2x is in the numerator, so we say 3 to the power 2x. There's a division line, 3 to the power 2x minus 1 in the denominator. So what happens, guys, the minute we go down to the numerator? What happens to the exponents? What happens, guys, to the exponents? 2x becomes negative 2x. Negative 1 becomes positive 1. Sign changes. Yes, Ngotuku, thank you so much. So guys, I hope we are understanding this. Any questions so far? Any questions so far? Right. Then, now we are going to simplify by adding and subtracting like terms for the exponents. We are going to subtract and add like terms for our exponents. Now we know, guys, that we only add and subtract like terms. Okay. Yes, Zim, you can. Okay, so Zim, Miss Zim in the comment section is asking, can I use law number 1 first for the numerator? Yes, you can do that. All right. Some people really insist on using law number 1 for the numerator. Okay, remember, at the end of the day, law number 1 and law number 2 need to be applied. So whether you want to apply it in segments, you want to apply it one step at a time, or you want to apply it all at once, is up to you. You are the master of your own destination, as long as law number 1 and law number 2 are applied fully when it comes down to it. If you want to apply it in steps and in bits, go ahead, right? But if you are capable of applying it all of it together at once, then by all means. Okay, so Ms. Zim is saying that applying law number 1 will help with avoiding sign mistakes. But remember, at the end of the day, it will depend on that particular learner. Yes, of course, some learners may find it quite, daunting maybe, to actually do the application of law number 1 and 2 all at once. Because here, we've applied law number 1 and 2 all at once. 2 to the power x minus 1. We see the relationship between this multiplication, we add 2x. Okay. Then we come down to the denominator, we subtract 4x because the sign changes. Remember, we said when we come down to the denominator, we always experience a change of the sign for our exponent. 4x becomes negative 4x, 2x becomes negative 2x, negative 1 becomes positive 1. Does that make sense? So all in all, it's really up to you. Okay, it's really up to you. Or you can do it separately. First, do the multiplication of the bases 2 to the power x minus 1 plus 2x. You get the answer for the base 2 in the numerator. Okay, so it's really up to you guys. It's really up to you. I prefer it this way. So if you prefer it in another way, that's fine. Okay, that's really fine, guys. So you do what is comfortable or most efficient and effective for you. Then, yes, they will be allocated the same, because at the end of the day, you're still going to get the same marks. So if this is a 5-mark question, if you do it separately, it's going to be allocated the same. Okay. Now, all we do now is we add and subtract the like terms for our exponents. So now we just need to collect like terms. You guys know how to add like terms. So let's first focus on the variable x plus 2x, because remember, this is x plus 2x. Maybe some people insist on actually first collecting and grouping the like terms. Some people may feel comfortable in doing it off the top of their heads. Guys, if you do it off the top of your head, it's very good. Okay, so x plus 2x minus 4x minus 2x. Those are the variable x's. They are like terms. Minus 1 plus 1. Okay. Okay. Three to the power. This is 2x minus 2x. The like terms are already sort of like grouped. So x plus 2x, guys, is what? 3x. Okay. Then 3x minus 6x, because 3x minus 6x, that's 2 to the power negative 3x. Then minus 1 plus 1 is 0. So in other words, we are just left with 2 to the power negative 3x for base 2. Let's go to base 3. 2x minus 2x, that's 0. 0 plus 1, that is going to be 1. Okay. Then remember, guys, our answer needs to be in positive exponents. We can't leave our answer as in negative exponents. Okay. So this is going to be 1 over 2 to the power 3x times 3. Okay, then this 3 times 1 in the numerator, that's going to be 3 over 2 to the power 3x, which can be written as 3 over 8 to the power x. And that's basically your answer. You leave your answer in positive exponents. All right. Okay. We leave our answer in positive exponents. Leave our answer having positive exponents. So what did I do here? Here I applied that law that says when a base is raised to a negative exponent, The answer is 1 over a to the power n. See, Keke is asking why 8? Because 2 to the power 3 is 8. That's why it's 8. And remember, I'm writing my answer simplified. Okay, so 2 to the power 3 at the end of the day is actually equal to 8. And then obviously the exponent is what? Is x. Okay. Okay. Ngwato, why did you not multiply? Because BEDMAS does not allow it. Remember BEDMAS? Brackets, exponents, division, multiplication, addition, and subtraction. Okay. 2 to the power negative 3x times 3. This here is a base. This is an exponent. We can't multiply 2 and 3 and say the answer is 6 to the power negative 3x. This is incorrect. Alright? Because BEDMAS does not allow it. Okay? Alright? Let me be practical with you so that you can understand what's 2 times 3 times 2. What if I said 2 times 2 is 4, and then I said the answer is 4 to the power 3? Is that correct, Ngato? 2 to the power 3 times 2. Can I say 2 times 2 is 4, and then say 4 to the power 3? 4 to the power 3, by the way... Oh, sorry. Let me just change this, because I know this one is going to work out. Let's say 2 to the power 5 times 3. Okay. Could I say 2 times 3 and then say the answer is 6, and then say 6 to the power 5, and then say 6 to the power 5? Let's check in the calculator. 6 to the power 5 is actually equal to 7,776. Thank you for the rows. No, thank you so much for the rows. 7,776. Okay, so multiplying, what I'm saying is BEDMAS as brackets, exponents. You have a base, you have an exponent. You can't jump to multiplication 2 times 3, but you have not resolved the exponent. That's what I'm saying. So we can't say 2 times 3 and say 6 and then say to the power 5. That's wrong. Okay, because BEDMAS does not allow it. Okay, brackets, exponents, division, multiplication, addition, and subtraction. Whenever we are dealing with a simplification, we have to take care of the order. We make sure that we do things in order. So if we say 2 times 3, it's inappropriate and incorrect, right? Rather, what's 2 to the power 5? It's 32. Then what's 32 times 3? You see, now we are talking about the difference. 32 times 3 is 96. Do you see this answer compared with this one? You see? So apply the exponent, then multiply. Because when you've applied the exponent, we are done here. Okay. All right. So that is basically the answer, simplified. Okay. Okay. So I hope we can then learn. Please leave answer when we simplify. Don't forget BEDMAS. Please don't simplify according to the order of what you want. Okay, yeah. So guys, I repeat, this is only when we have multiplication and division in our expression. and we have number bases with exponents as our variable. Okay, does that make sense? Yeah. So hopefully you understand. Great, Scott. Okay. Hopefully the 3 times 5 to the power 3 times 4. This is an expression. So in your head, you are thinking BEDMAS. Why? Because BEDMAS says you start with your brackets. Okay? Brackets. So inside your brackets, you have 3 times 5. You can work it out. What's 3 times 5? It's 15. Right? So brackets can be taken care of. Exponent. You apply your exponent to the bracket. Because E means exponent. You apply the exponent. So you can go to calculate, say 15 to the power 3. What's 15 to the power 3? It's 3,375. Okay. Exponents done. Division? No. Multiplication? Yes. Now you can multiply these two. What's 3,375 times 4? That gives you 13,500. Okay. So guys, please, BODMAS, BEDMAS. Okay, brackets, exponents, division, multiplication, addition, subtraction. Okay. Yeah. So when we get to the simplification stage after adding and subtracting the exponents, please guys, when we are about to simplify here, we must remember BEDMAS. And then of course, don't forget the law that says when you have a base raised to a negative exponent, you can write that particular negative exponent as 1 over the same base raised to the same exponent, but just positive, not negative. That's basically what we do with this. You multiply that with 3, and then you should be able to simplify and get to the answer. Okay. Great, Scott. That O, I said to you guys earlier on that I'm busy here cooking for grade 8. Okay. So if you guys have brothers and sisters that are in grade 8 and 9, they want to actually have someone that can actually walk with them throughout the maths journey from grade 8 all the way to grade 12, you can send them in my direction. They can come to my inbox, send me a message, they can speak to their parents, and we can actually arrange something for that, so that a WhatsApp group can be established. We can actually have that happening. In actual fact, the WhatsApp group is already there for some of the grade 8s that have indicated that they would want to basically be in a gen. So guys, look at this. BODMAS, in actual fact, let me just explain something. Let's clarify something. Brackets mean brackets, of course. The O means order of powers or roots. Order of powers or roots. Powers have to do with what? Exponents. So here we are dealing with exponents and roots. That's what the O means. Okay. Then division, then multiplication, then addition, then subtraction. Okay. So if you are a grade 8 and 9 learner, you want to basically be supported in your maths journey throughout the year 2026, so that distinctions can be part and parcel of your walk and journey, please send me an inbox message. We can take it from there. Okay, I need to move on now. Okay, so remember, this problem had to do with multiplication and division of exponents only. What did we say are the steps? We look at the numerical bases, we change them from prime bases from composite bases to prime bases. All right. Then after that, we apply law number 3. We then apply law number 1 and 2. We simplify by adding and subtracting exponents. We apply BEDMAS where necessary and make sure we leave our answer as positive exponents. And that basically is how we were able to get to 3 over 8 to the power x. Let's look at another problem. Let's look at another problem. Grade 11. Okay. This is grade 11 for those who are asking, wondering. Okay, let's look at another one. Still dealing with multiplication and division. Still dealing with what? Multiplication and what? And division. Let's see. 8 to the power x minus 1 times 3 to the power negative x minus 1 over 1 over 4 raised to the power negative x times 6 to the power x minus 3 times 9 to the power 1 minus x. So this is division, and we can see multiplication. So when we have multiplication and division only, then we know that our steps are very straightforward and simple. Guys, factorization is only applied when there is multiplication, division, but also there is addition and subtraction between the bases. The minute plus and minus are introduced between the bases, that's when you start thinking of what? Of factorization. Right now, guys, we are not even thinking of factorization because the problems that we are dealing with here, to start us off, have only multiplication and division between the what? Between the bases. So I'm trying to answer the question for the person who was asking, when do we factorize? When do we factorize? Guys, factorization is only going to be applied when there is a plus or a minus sign between our bases. So far, we are not there yet. I'm still trying to drill in the concept of what do we do when we are multiplying and dividing between bases. Are we together? So flow with me here so that you can be with me, and you will see the difference between the questions. All right? Okay. So here now, I know, Katimeb, you were the one that was harassing me in the comment section, and I just wanted to clarify that for you so that in your head, why is it that most of the time people are unable to do the right thing? It's because when they are looking at a particular question, they don't know what they are dealing with. Katimeb, it's like not knowing. If I give you an orange and I say eat the orange, I sure hope, for the life of me, I sure hope I'm not going to see you eat that orange like you are eating an apple. You grab that orange and you okay, because you know the difference between a what? A orange and an apple. So when you're eating an apple, you can just take that apple, but with the orange, peeling has to happen. I give you a banana and I give you an apple. Okay, so that's why I'm saying with multiplication and division, there's certain things that you do here that are unique to this, and I've explained the steps. Okay, so once again, multiplication and division, we look at the what, guys? The bases, and we do what? We convert the bases from what? From composite to prime. So we have 8 here. 8 is a composite number. It has more than 2 factors. Let's change this composite base to a prime base. 8 can be written as what? Thank you, Iconic Sia. I see you there in the comment section. 2 to the power 3. We put brackets around at 2 to the power 3. Then we write x minus 1 as an exponent. Very good, Iconic Sia. Iconic Sia, you are iconic. Okay. Please, guys, thank you so much for the likes. We have 20.9k likes. Let's continue liking and double tapping on the screen so that we can get the likes up there. Those who are able to gift, guys, please let us exercise our powers of gifting. I really appreciate it. The support, it means a lot when it is possible. And yeah, let us comment in the comment section if there are things that are asked so that we can actually be proactive and also engage, because at the end of the day, this is not about me. I know the maths, but it's about you also internalizing it for yourself. 3 is already prime, so it's fine. This one, it's fine. Okay, no brackets needed, no conversion of that prime base. The prime base is fine. Now guys, here 1 over 4. Guys, please take note, 1 over 4. Okay, I'm just going to, on the side, write down 1 over 4. Guys, 1 over 4 can be written as 1 over 2 to the power 2. Are we agreeing? Okay, then we can write that as 2 to the power negative 2. Can I get an amen here? From here to this, and from this to that. Do we understand what I did here? I changed 4 to a exponent, which is 2 to the power 2, right? Oh, Levis, thank you so much. So the amen is amening. Okay, Avila, thank you so much. So 4 can be written as 2 to the power 2. How did I know that 4 can be written as 2 to the power 2? It's because if I don't know off the top of my head, I can take my calculator and say 4 is equal to shift fact. Four is equal to shift fact. Okay, remember calculator, 4 is equal to shift fact. So the 4 is 2 to the power 2 in the denominator. Then I can then use my law, this one. Which law? Any base 1 over a to the power n. Remember guys, I can write this fraction as a exponential base a raised to the power negative n. What happened? Base moved from the denominator to the numerator. What happens when we move a base from denominator to numerator, or numerator to the denominator? The exponent changes sign from positive. Now I have a to the power negative n. The one that was there is still there, but multiplied to a in the numerator. So therefore the answer is 2 to the power negative 2. So here it's like saying 1 times 2 to the power negative 2, which is that. So if I want to write 1 over 4, I can express it as 2 to the power negative 2 if I go straight to the point. Okay, then this is negative x. Remember, there was a negative x, so I keep that negative x outside the bracket. Brackets, guys, when I convert 8, I write 2 to the power 3 in brackets. When I convert 1 over 4, I write 2 to the power negative 2 in brackets. Okay, moving right along. 6. Okay, when all else fails, guys, 6 is equal to shift fact. There, calculator gives me 2 times 3, or I can write it as 3 times 2. It's up to you. 2 times 3. Keep the exponent x minus 3. 9. Don't know? 9 equal shift fact. Voila. 3 squared. Thank you, Ngotuku. 3 squared. Okay. Both, Katy. Both. Okay. I can do private as well, and yeah, I will be going live, but not as often because I'll be busy, obviously. But when I can, we'll go live and assist. But yeah, if you want private tuition, just make sure you hit me up privately, send me a message and let me know. Okay. Yeah, so far are we okay, guys? Are we breathing? Like we're having some sense of like understanding of what's happening here. Okay, yeah, let's become confident in this. When there's multiplication and division, we don't think too much. We look at our composite bases, we convert them to prime bases, and there's ways, guys, we can do it. It's doable. Now we apply law number 3. Remember I said we apply law number what? Law number 3. So 3 is a monomial, x minus 1 binomial. We distribute, multiply. This is where sometimes learners fail. Sometimes learners will say 3 times x, but they'll forget to multiply this 3 with the negative 1. And that's where basically things go wrong. Because remember, if you multiply wrong, then it means that you are going to get like terms that are incorrect, and your answer is going to be incorrect. So let's make sure, guys, monomial by binomial. Mono 1, binomial 2 terms. So you distribute 3 times x, 2 to the power 3x. 3 times negative 1, negative 3. Please, guys, that is one thing that I want to stress more than anything else. You multiply 3 and x, you multiply 3 and negative 1. This one was fine, already sorted. We go down, multiply. We're applying law number 3, guys, everywhere where there was the bracket. Negative times negative. Okay, remember my S and L. We multiply the sign 2 to the power positive. We multiply the number 2 times 1 is 2. We multiply the letter x combined. So our answer is 2 to the power 2x. Then remember here, 2 and 3 as are bases that are multiplied. We take the 2 to the power 1. We multiply there. So it's 2 to the power x minus 3. Base 3. 3 to the power x minus 3. Okay. We come here now. The last and final base. Same thing. Monomial by a binomial. This is like saying 2 into 1 minus x, guys. You distribute. You see? Please, guys, please, please, please. 2 times 1. 2 times negative x. Positive times the negative is negative. 2 times 1 is 2. And then the x combined. This here, 100% step. Do you see this, guys? Okay, any questions? Any questions at all? We need to be masters, guys, with this. Masters of multiplication and division of exponential expressions. Okay. Yeah, if Nilo, you just joined, then of course all you heard is negative. Okay. You just joined, so if you just joined, of course that's all you heard. Okay, then we're going to apply. So we've applied law 3. Now it's time to apply law number 1 and 2. Whether you decide to apply those separately or together all at once, that's really up to you, guys. Remember that. Okay, so I have base 2 here, base 2 at the bottom, 2 of them. So let's start with base 2 and collect the exponents. 3x minus 3. We've accommodated that. Done. Remember, when we go down, what happens? When we go down and collect the exponents for base 2 in the denominator, our exponents become what? There's a sign change that happens. Because that's like taking this exponent to the numerator. 2x will become negative 2x in the numerator. X and minus 3. This x is positive, so it becomes negative x. This negative 3 becomes positive 3. The sign change happens, guys, with the exponents in the denominator. Okay, it's the application of this law, guys, of this definition. We are applying it directly because the relationship between our bases is one of multiply and divide. So law number 1 and 3 and 2, law number 1 and 2 can be applied freely when it's only multiply and divide between the bases. It cannot be applied freely when there's plus and minus between the bases. Hence, we talk about factorization in those situations. Law number 1 and 2 applied freely when there's a relationship of multiply and divide between bases. Then we go and take base 3 now. Base 3 in the numerator, signs stay as they are. In the numerator, the signs remain as they are. In the denominator, when we take it up, it means we are going to experience a what? A sign change. Guys, it's a sign change that we are experiencing. So this x is positive, becomes negative x. The negative 3 becomes positive. The positive 2 becomes negative. The negative 2x becomes positive. The step is 100%, guys. Full marks are coming. It's like full marks are crying for me. They're like, I want to be one with you. Okay, finally, let's continue. Now we add and subtract like terms. Then make sure we apply bad mess where the need arises. Okay, add and subtract like terms. Okay, now remember, the last time I collected the like terms, but it's not necessary to write the collection. You can just say 3x minus 2x. What's 3x minus 2x, guys? It is x. Then what's x minus x? It's 0. So we have 2 to the power 0. Minus 3 plus 3 also gives me 0. And 0 plus 0, guys, is 0. So I have 2 to the power 0 here. Let's go to the 3. Base 3. Negative x minus x is negative 2x. Then negative 2x plus 2x is also 0. 3 to the power what? 0. Let's go to the numbers now. Negative 1 plus 3 is positive 2. Positive 2 minus 2 is also 0. And 0 plus 0 still gives me 0. Now what's a base raised to the power 0? It is 1. What's another base raised to the power 0? It is 1. Where do you get that? From your laws. What's the final answer? 1 times 1, bad mess. Multiplication is 1. 1 times 1 is 1. 1 plus 1 is 2. Snoko. Snoko. Vulama boto. Hey, Jaiva Snoko. Vulama boto. Yeah. Not 1 plus 1 here. We say 1 times 1 is 1. Snoko. Snoko. Vulama boto. 1 times 1 is 1. Okay, so there we go, guys. 1 times 1 is 1. Okay. Please, guys, 1 times 1 is 1. Not 1 plus 1. Not 1 times 1 is 2. Snoko. No, Snoko. No. Okay. So 1 times 1 is definitely going to give us 1. Okay. Guys, are we feeling this? It's coming, eh? Multiplication and division. The steps are straightforward. Okay? The steps are straightforward. No difficulty. I'm going to do one last one with multiplication and division. One last one. Then I'm going to move on to addition and subtraction so we can see the difference. One last one, guys. With just multiplication and division. One last one. Okay, one last one. Okay, 6 to the power negative x minus 2 times 3 to the power x times 3 over 18 to the power x minus 1. Okay, first step, we check the bases. What relationship do they have? Multiply and divide. There's no addition and subtraction. So in our heads, we don't have to worry about factorization. What we are worrying about is converting the composite bases to what? To prime bases. Miss Zim, it's not a sin at all to type in 1 times 1 and get the answer. In actual fact, let me just suggest that even with the addition of like terms, I've seen learners, guys, add like terms incorrectly here. And that's where it kills me, because if you are not able to add like terms correctly, it means that you are struggling with grade 8. Now imagine you are in grade 11, you are doing this problem, but you are struggling with addition and subtraction of like terms. Let us specifically look at this actual problem. You have problems with adding and subtracting like terms. You have a grade 8 issue in grade 11. So guys, please, you see this guy, use him. Use the calculator. Use the calculator. So Miss Zim, you're bringing up a very important point, that grade 11s, don't be ashamed to punch in the calculator, you know. So for instance, I know that when I add like terms, I'm keeping the variable obviously, but I'm adding the coefficients. So 3x minus 2x minus x, for instance, I know x is supposed to be a variable that's going to be there, but I'm going to say 3 minus 2 minus 1. So you go to your calculator, because some of you, I don't trust you. 3 minus 2 minus 1, it's 0. So it's 0x, which is basically 0, right? You go on to the number minus 3 plus 3. Hey, some of you will write funny things. Hey, minus 3 plus 3 is 0. So that's why at the end of the day I have 2 to the power 0, because in the exponent my addition of like terms leads me to 0. Please guys, be sure of what you are writing down. Here, same thing, because we don't want to mess up near the end. It's painful to mess up at the end. I hope you get my point. Okay, let's go on here. Okay, relationship is multiply and divide. It's M and D. So if it's M and D, then I know I'm going to convert what? My composite base to prime bases. 6, we know most, in brackets 2 times 3. Then we keep what's outside. 3 is already prime. This 3 is also already prime. So I'm just going to reveal the hidden exponent, because I tell you what, people tend to forget that this 3 has an exponent 1. Reveal what is not seen, guys. Reveal. Alright? Over 18. Well, maybe my head is not working quite well. So what I do is I take my calculator. I say 18, because 18 is a composite number. I press equal. I then press shift. And then I press fact. Who's fact? There we have it. There. Okay. It even provides the exponential form. So yes, Ngotuko, it's 2 times 9, but you see my calculator does one better than you. 2 times. My 9 is still a composite number. I don't want composite numbers, guys. I want to have bases that are prime numbers. Okay. So one better than you, Mr. Ngotuko. 3, you can put multiply, you can put the dot. Okay, remember the dot and multiplication mean the same thing. Then you keep the x minus 2 outside. X minus 1. These are common mistakes that people make. You write the wrong thing. It's x minus 1. Make sure, guys, x minus 2, it's x minus 2. It's x. It was 1. Yes, we make sure with the 1 we show. It was x minus 1. It's still x minus 1. Don't make a silly mistake by writing what is not in the question. Now, after converting composite base to prime base, the next step is to apply law number 3. Law number 3. Base multiply the exponents. 2 to the power 1. So that's going to be 2 to the power 1. It's going to be 1 times x is x. 1 times negative 2 is negative 2. Snoko. Vulama boto. Then 3 to the power x minus 2. 3 to the power x minus 2. So this base exponent x minus 2 multiply this base x minus 2 times, we have the 3 to the power x times the 3 to the power 1 over. Now, law number 3 again here in the denominator. This 2 partake 2 to the power x minus 1. This 3 distribute 2 times x, 3 to the power 2x. 2 times negative 1. Remember, guys, we multiply by distributing the 2. Distributive law, right? Distributive law. 2x, 2 times x is 2x, 2 times negative 1, negative 2. Law number 3 has been applied successfully. Step 3, law number 2 and 1. 1 and 2, guys. We apply the 2 laws, law number 1 and 2. Then let's connect bases. Let's start with base 2. Base 2, we have x minus 2 at the top. It's the only base that has base 2 in the bottom. So we are going to say x minus 2. Let's go down. X will become negative x. Negative 1 will become positive 1. Sign change. Let's not forget, guys, that with the division we have sign change. Very important. Okay, then we collect base 3. Base 3, x minus 2 as it is, still in the numerator, plus x as it is, still in the numerator, plus 1. We go down to the denominator. What happens because we are going down? The exponent 2x becomes negative 2x. Negative 2 becomes positive 2. Then, of course, from there, oh lo lo, oh lo lo. I'm sure you guys are busy. Festive vibes there, some of you. Okay. Let me take a moment here. I can see some of you. You are still in your pajamas, sleeping on the bed. You are taking out the phone, or the phone is taken out, and you are still in your PJs watching grade 11 maths, exponents being done. Can I get an amen? I can see some of you. There's no pen, there's no paper, there's no book in front of you. You know, you are scrolling through, you've just arrived, you see this thing happening, you are stressing because you're like, what? This guy is doing maths. Maths in December. This guy is harassing us. All these things. All right, anyways, let's continue, guys. Here now we add and subtract. Step number 4. We add and subtract like terms. Okay. Yeah, and remember, guys, don't be afraid to use your calculator, right? Don't be afraid to use your calculator if the need arises. Okay, please don't be afraid to use the calculator for adding like terms, because at the end of the day we want to make sure that we have the correct addition. So x minus x is 0. Then minus 2 plus 1 is 2 to the power negative 1 times x plus x is 2. 2x minus 2x is 0. Then we look at the constant minus 2 plus 1. That gives you negative 1, and negative 1 plus 2 gives you 1. So that's 3 to the power 1. Okay. Finally, 1 over 2 times 3. 2 to the power negative 1 can be written as 1 over 2. Then that means our answer is 3 over 2. Finally. Okay. Right, guys, like terms. 5. Let's not forget that definition. This definition seems to be really a common feature at the end. The definition, not forgetting, of course, BEDMAS, so that we get our final answer that we need to get at the end. All right. Okay. I think, guys, you really like I don't know, Tato. If you send me the DM, then I'll definitely attend to it after I'm done with the live. I unfortunately cannot look at the DM now, but if you've checked out the DM, great, that's fine. I'll check it out. Okay, and I'll attend to it. Okay, now let's turn over our attention now to addition and subtraction. What do we do in situations where there is not just division and multiplication, but there is addition and subtraction as well between our bases? Now, that's where you guys now need to pay a bit of attention, because when between bases, there is not just multiplication and division, but there's subtraction. that's where now you need to take note of a few things. All right, and hopefully you are with me now. I'm going to do 3 problems that are not the same, that require us to apply different things. The first problem that I'm going to look at as an example, okay, and I hope you guys will be paying good attention, is this one. This is the first problem. Four times 3 to the power x minus 3 to the power x minus 1 over 11 times 3 to the power x plus 1. All right, so if you look at this particular problem, it is very clear as you look at it that it is very different from the 3 problems or examples that we have just looked at. Why? Because what do we see in the numerator? 4 times 3 to the power x. So this is familiar. But now this here, the minus sign, is unfamiliar. 3 to the power x minus 1. We did not have a subtraction or addition sign between our bases in the last 3 problems that we looked at. But in this one we do. If you look at the denominator, we have 11 times 3 to the power x plus 1. Now, for anyone who's looking at this problem, they're like, okay, this is very interesting, but what approach do we take when there's a minus and a plus sign between our bases? Now, please listen and listen very well. Let us analyze what we have. We have 4 times 3 to the power x. Take note. In the numerator, how many terms? If I asked you how many terms do we have in the numerator, you would say how many terms do we have? How many terms specifically in the numerator, not in the denominator? Yes, Ketimeb. There are 2 terms in the numerator. Why do we say there are 2 terms, guys? It's because terms are separated by a plus and a minus sign. In the previous 3 problems, we did not have a situation of terms being separated. But now we have a situation of terms being separated by a what? By a plus or a minus sign. Now, seeing that that is the case, that means then to me and you that we have to look at the situation of the bases for all terms. So if you look at the first term, we have 4 times 3 to the power x. The number is 4 multiplied by the base, which has a variable. The base with a exponential variable is what we focus our attention on. So the first term has a variable x. Are we together for the base? And the base is 3. That's the first term. Look at the second term. We have a base 3, which also has a variable exponent, which is the same as that one. All right. So if our base with the variable exponent, okay, sometimes that base is prime, sometimes the base is not prime. But for our prime base with an exponential variable that is the same, why do we say that the exponential variable is the same? It's because the coefficient of this x is 1 for base 3. And the coefficient of this x is also 1 for base 3. So that means we have a common what, guys? A common prime base with the variable exponent that's there. Remember guys, a variable is simply what? A letter of the alphabet. So if that is the case, then that means in our factorization, we are going to have a common factor. And that's what we are going to take out. But before we do that, step one, we split the bases. So that's like doing the reverse of law 1. Alright, because the reverse of law 1 is that if you have a to the power m plus n, this is like saying a to the power m times a to the power n. Even a to the power m minus n, guys, I can write this as a to the power m times a to the power negative n. I hope it makes sense. So the reverse is when you take this and yeah. I think you guys get the point. This is the reverse of the law. When you are multiplying same bases, what do we say we do? We add the exponents. So I can take these exponents that are added and write them as a separate bases of a to the power m times a to the power n. That's what I mean by splitting the bases. Okay, so we are going to come here now in this numerator, and what are we going to do? We are going to split the bases. But the only reason why we are doing the splitting of bases is because, guys, for the two terms we have there, we can see that there is a common prime base with the same variable exponent. That's why we do the splitting. The splitting is not done if there is no evident common base, common prime base. So let's come here. Let's split 4 times 3 to the power x. The first term is already split. The second term, though, needs to be split. So the second term is 3 to the power x times 3 to the power negative 1. Okay, please take a look at what I've just done and confirm to me as to whether you are okay or not. 4 times 3 to the power x, that's fine as our first term. 4 times 3 to the power x, that's already split. 3 to the power x minus 1 can be written as 3 to the power x times 3 to the power negative 1. We are splitting using this reverse idea. Okay, this can over 11 times 3 to the power x, we split that, that's 3 to the power 1. Reverse of law number 1. We split 3 to the power x plus 1 to become 3 to the power x times 3 to the power 1. Step 1. Step 2, we take out the common prime base with the variable exponent, if possible, where possible. So in the numerator, okay, because we have a subtraction sign, we can factorize. That's what we mean by factorize. By taking out the common prime base, we are actually doing highest common factor factorization. So what is common? Term 1 and term 2. Hello Peanuts, good to see you, buddy. Peanuts Snorko. Yeah, Peanuts has been having the time of his life, doing all sorts of things with the gigs there. Content is always interesting, buddy, always interesting. I'm literally your fan. And I can say that clearly and purely. So 4 times 3 to the power x minus 3 to the power x times 3 to the power negative 1. In the numerator, guys, what is common? It's 3 to the power x. Are we together? 3 to the power x. All right. Iconics here is laughing. Guys, do you know why Peanuts is my fan? The only reason why, like, one of the things that really make me love Peanuts is the fact that one, I think he's a learner who's going after his dreams. Still in high school, but he's going after his dreams. He's unapologetic about going after his dreams. Not too many people have the courage to do that. Two, the fact that he does not drink. He does not drink alcohol. So those are the two reasons. Anyways, 4 times 3 to the power x minus 3 to the power x times 3 to the power negative 1. You take out 3 to the power x, what are you left with on the left? You take out 3 to the power x, we are left with what on the left? 4, right? Are we together? Yeah, I hope we are together so far. Then on the right, what's left? Minus 3 to the power negative 1. Okay, are we together so far? Together so far? Okay, then we go to the denominator. Go to the denominator. 11 times 3 to the power x times 3 to the power 1. Now, we can cancel, simplify. Why is that possible? Why can we cancel, simplify? Because, guys, because we do not cancel across an addition sign. We can't cancel across a plus or minus sign. We can't. But because we've taken out 3 to the power x, and we now in the numerator don't have 2 terms, but now in the numerator we have 1 term, it becomes easier now to go ahead and cancel 3 to the power x there and that 3 to the power x there. It is something we can do because the 3 to the power x is outside the bracket, and this 3 to the power x has a relationship with its basis of just multiplication, so cancellation can happen, right? What are we left with in the numerator? 4 minus 1 over 3. Okay, remember when you cancel, you are left with 1 and 1 here. Okay, then in the denominator you have 11 times 1 times 3, which is actually equal to what? 33. Okay, and guys, really and truly at this point you could actually grab your calculator and say 4 minus 1 over 3 without really using much. You are going to have 11 over 3 divided by 33, which is simply 11 over 33 times what? Times 1 over 33. 11 over 3. And your final answer. Now for most of you, I'm sure you are like maybe a bit lost here. 4 minus 1 over 3 is 11 over 3. Remember, 11 over 3 divided by 33 is actually 11 over 3. You change the times to divide. Divide to times. Then what happens to 33? It becomes 1 over 33. So that's where this comes from. Then 11 times 1. 3 times 33, and 11 over 99 is actually equal to 1 over 9. And that's that. Okay. So this is, I guess, your taking out your highest common factor, factorization, if you want to put it like that. Okay, all right, guys, if there's any questions, please ask your question if there's any particular question that you guys have about what you see there. Any question, any at all. Miss M, oh God, I'm late. The fourth stage, Mapule. You mean the simplification? Okay. So here, so this here, the stage that Mapule is saying I must repeat is actually grade 8. Okay. Me, I like saying these things because here, from here onwards, you are dealing with a grade 8 problem. Okay. So 4 minus 1 over 3. All right, what is that? What's 4 minus 1 over 3? It is 11 over 3. How did I get that? I simply just went to my calculator and I just said 4 minus 1 over 3. Okay, which helps me out a lot there. I get 11 over 3. Thank you, Loki, for the heart me. Okay. Then that's all over what? 3. Okay, but let's interpret what this means. This is 11 over 3. The line here means what? Divide. This line here means divide. We are taking 11 over 3, we are dividing it by 33. So it's like saying 11 over 3 divided by 33. Okay. If we rewrite the 11 over 3 divided by 33, remember this is 33 and 33 can be written as 33 over 1. This is like saying when you change the divide sign between a division of two fractions, this is back in grade 8, grade 7, guys. You change divide to multiply. What happens to the second fraction? It becomes 1 over 33 because this swaps. When you change divide to multiply, the second fraction swaps. Then that becomes 11 over 3 times 1 over 33. Are we together? Yeah. Then you can now multiply. Okay. Yeah, you can simply multiply. 11 times 1 is 11. 3 times 3, 33 is 99. And then obviously from your calculator, even when you say 11 over 99 and you say equal, your calculator will give you 1 over 9. Okay. Okay, we good? Yes, Remo, KCF. KCF. So Happiness and Remo, would you guys care to explain what do you mean by KCF? What does the K and the C and the F stand for? Because I think some people keep, change, and flip. There we go. Division, 33 over 1. You change the division to multiplication. You flip the fraction. Okay, so you see some people here keep, change, flip. You flip the second fraction. 33 over 1 becomes 1 over 33. So that's why you see me here. I did this mental 11 over 33 over 33. I just simply wrote 11 over 3, keep, times, change the divide to multiply. What happens to the fraction? 33 becomes 1 over 33. And then you simplify from there. Okay, thank you so much, Remo. That explanation is very much helpful. KCF, guys. This has to do when you are dividing two fractions. If you are dividing two things, you keep the first fraction, you change the divide to multiply, and then you flip what your second fraction would be. From 33 over 1, you get 1 over 33, and then that final answer. Okay, thank you guys. Remo and happiness, you are making us Remo and happy. Okay. Right, I'm gonna do 2 more problems and that will be it for today, guys. Okay, that's type 1. Now I'm looking at a second type of problem that you can get where there's addition and subtraction. Okay, so please take note of this problem. 5 to the power 2x. You're welcome, Mabule, and thank you guys in the comment section. You see how valuable your insight is, guys, in the comment section. It doesn't go unnoticed. It's quite valuable and it's really helpful because it makes a world of a difference when people are able to actually like go ahead and share their insight. It makes a world of a difference. So thank you so much. Much appreciated. Much appreciated. Okay, 5 to the power 2x plus 5 to the power x plus 1 minus 6. So in the numerator this time round, we have how many terms? Okay, remember initially this one we had 1 term and we could see that the bases easily have the same variable exponent. But look at this time round. Base plus base minus. In the numerator, we have 3 terms, guys. So in other words, here we have a trinomial, right? And it seems to be a specific type of trinomial. 5 to the power 2x plus 5 to the power x plus 1 minus 6. Look at the space 5. Coefficient of x is 2. Look at the space 5. Coefficient of x is 1. Then there's a constant term, right? So this type of trinomial here is actually quadratic as well. It is also what? Quadratic. 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 Quadratic what? Quadratic trinomial. Okay. So there's something I want you guys to see. All right. I want you guys to see something here. And that is 5 to the power 2x plus 5 to the power x plus 1 minus 6 is a quadratic trinomial. Okay. How so? Because, guys, 5 to the power 2x can be written as 5 to the power x squared, if you think about it. All right. This 5 to the power x plus 1, if we were to actually split it, would be written as 5 to the power 1 times 5 to the power x. And this would be minus 6. Okay. So what you are seeing is that base 5 exponent to base 5x times 1. Okay. So these are 3 terms in the expression, which means we can actually factorize this, but not in the common way of factorizing, as in like taking out the highest common factor, because 5 to the power x is not common for all 3 terms. Rather, we see that this is a trinomial and it's quadratic in nature. So there are 2 things you can do here. You can either let k be equal to 5 to the power x, and if you rewrite this, this is like saying k squared plus 5k minus 6. If you let k be 5 to the power x, the base with the variable exponent that is 1, the coefficient of x is 1. This means this is k squared plus this 5 is multiplied to 5 to the power x, which is k. So that is 5k minus 6. So that's why I was saying this is a trinomial that is quadratic in nature. You can factorize this trinomial because you've been taught how to factorize a trinomial that is quadratic in nature. Remember guys, quadratic just means that the variable with the highest exponent is 2. Okay, so that means you can actually factorize this quadratic trinomial. Okay, you can factorize it and factorize it well. All right, so I hope we can see this, the difference between this problem and that one. This one, all we needed to do was to just split the base, because we could see that for the prime base that is common, the variable x has the same coefficient 1, 1. Even if it was coefficient 3, 3, it still means we have a common base, which is prime, that has the same coefficient for the variable. But in this situation, the prime base 5 does not have the same coefficient, but it is 2 times the other variable. When that is the situation, guys, when you can clearly see that for 2 different terms in a possible trinomial, one coefficient of x is 2 times the other, that says to you, and it speaks very loud to you, that that is quadratic in nature. It's not your common, highest common factor type of exponent, but it is your trinomial type. So as I said, 2x can be written as 5 to the power x squared. So how many 5 to the power x's do I have? 2 of them. Whereas this term I have 1 5 to the power x, and then this is a constant -6. For 3 terms that are a trinomial, this is quadratic in nature. Can we factorize this? Yes. Remember how to factorize a trinomial? What do? We open 2 brackets. Okay. Then k squared. We can write k and k here. And then what are the factors of 6? Which when we multiply give us -6, but when we add them give us +5. Remember guys that a minus sign for your constant term means that the signs in your bracket will be different. So you are going to have a plus and a minus sign, because minus suggests that you are going to have different signs. Then your sign that is positive in the middle suggests what? That your highest factor is going to have a positive sign. So if you think about the factors of 6, you have 6 and 1, you have 3 and 2. The highest factor we've already established will be positive, whereas the other one will be negative. So which one works? Is it 6 and -1, or is it 3 and -2? When we multiply this, we get -6, both of them. But when we add them, which one do we get +5? Is it 6 minus 1 that gives us 5? Or is it 3 minus 2 that gives us 5? So what are the factors that work? Is it 6 and -1? Or is it 3 and -2? Okay, which one works in this particular situation? Okay, hopefully we can see the one that works. Is it 6 and -1? Or is it 3 and -2? So obviously it is what? 6 and -1. Okay, so those would be our factors. Okay, definitely those would be our factors. So what are we saying in essence? We are saying that the numerator here can actually be written as, remember k is 5 to the power x, can be written as 5 to the power x plus 6 minus 1. When we factorize this, it's actually 5 to the power x plus 6 into 5 to the power x minus 1. That's what this here can be written as factorized. All right. So let's do this. 5 to the power x split this. Can be written as 5 times 6. Now I deliberately say 5 times 6 because I'm going to have in the numerator a common factor. So obviously factorizing this at the top leads me to 5 to the power x, remember, plus 6 minus 1, all over what? Now in the denominator, there is a common factor that I can see as well, which is what? It is 5. All right, I take out the 5. All right, yes, it's important that they escalate because, guys, remember, between the terms in the numerator we have a plus and a minus. In the denominator we have a plus. So in our head we are like, well, if we look at the numerator, what are we going to apply in order to simplify our numerator? We are going to apply quadratic trinomial factorization. Then in the denominator, we can see we have 5 to the power x plus 1 plus 30. We split this 5 to the power x because it's our first term. This is our second term. We split 5 to the power x plus 1 as 5 to the power x times 5 to the power 1. Then 30. Because, guys, I can see there's a 5 there, I split this so that at the end of the day, it can actually help me take out the common factor that is possible to be taken out in the denominator. Okay, so 5 to the power x plus 1 can be written as 5 to the power x times 5 to the power 1. That should be fine. 30, guys, can be written as 5 times 6. You know that. Okay? 30 can be written as 3 times 10. Or it can be written as 5 times 6. Or it can be written as 15 times 2. I just so happened to take the product of factors that I can see will actually suit this particular situation. Right? So I wrote 30 as 5 times 6 because the product of factors that will suit the situation I can see is already unraveling is 5 times 6. So if now in the numerator, what can I do? I can take out a highest common factor. What is the highest common factor that you see here? What's common for the denominator? What is common? It is 5. What is left inside? 5 to the power x on the left, 6 on the right. I'm sure now you can see, because we can cancel for simplification. Why can we cancel for simplification in this case situation? Because remember, we cannot cancel across an addition or a subtraction sign. But what do you see now at the top? How many terms are there on the top? 1. How many terms are there in the bottom? 1. So therefore cancellation is now made possible. So that means this here and that there simply say goodbye. What are we left with? 5 to the power x minus 1 in the numerator over 5 in the denominator. And guys, we can't go any further. We can't simplify any further. You can't cancel this 5 and this 5. Why? Because we cannot cancel across an addition or subtraction sign. It goes back to what I said here. We can cancel or simplify, no? But we do not cancel across a plus or a minus sign. You can't cancel this 5 and this 5. You can't, right? You can't do that. Okay, so that is the final answer, left as you see it being left there. So here, guys, factorization plays a role, because when we are dealing with an expression in the numerator, such as the one that you saw there, factorization is applied because we have a quadratic trinomial. Remember, what did I do to see that it's a quadratic trinomial? I first asked how many terms are in the expression. There are 1 plus 2 minus 3 terms, because remember, terms are separated by a plus and a minus sign. Step number 2, when you look at the actual expression 5 to the power 2x, it can be written as 5 to the power x raised to the power 2. plus, you split these two using the reverse of law number 1. That becomes 5 to the power 1 times 5 to the power x minus 6. 3 terms means that we can actually factorize this because we look at the variable 5. With x, the exponent is 2. With the other term, the variable, the coefficient, the base 5 has the variable x. For the exponent for the same base for different terms, the coefficient is 2 times the other one. When it is 2 times the other one, guys, the minute you have same base for different terms and you see a situation where the coefficient for x, the variable, one is 2 times the other, that immediately says to you, we have a quadratic expression. Therefore, we can factorize. For 3 terms, you can factorize that quadratic expression using your factorization. So 5 to the power x is common for these 2 terms. This one has the exponent 2, this one has the exponent 1. Therefore, what do we say? We let k be equal to 5 to the power x. The base that has the lowest exponent, not the one that has the highest exponent, the one that has the lowest exponent, because 5 to the power x is common. We let that k be 5 to the power x. In the place of 5 to the power x, we can substitute and write k. This becomes 5k minus 6. So this trinomial can be factorized like this. All right. This is grade 9, guys. Grade 9, you learned how to factorize a trinomial. Grade 10, you further, confirmed it. Grade 11, you should be solid at this point. Factorizing a quadratic trinomial shouldn't be an issue for you. There we have it. Okay, so that means if this is k plus 6 into k minus 1, remember k was 5 to the power x. That means in the place of k, I'm going to write 5 to the power x plus 6 into 5 to the power x minus 1. So this factorized is that. The numerator required us to factorize using our understanding of factorizing a quadratic trinomial. Okay. Then in the denominator, we are not solving for here we are simplifying. So don't say k is equal to negative 6. Here we are not solving, we are simplifying a exponential expression. For you to say k is equal to 1 and k is equal to negative 6 means you are solving an equation. We are not solving an equation. We are simplifying an exponential expression where the numerator has a plus and a minus sign and the denominator has a plus and a minus sign. If we go to the denominator now, we have 5 to the power x plus 1 plus 30. 2 terms in the denominator. So we split 5 to the power x plus 1 to be 5 to the power x times 5. There's a 5 here, guys. Then it means 30 needs to also be what? We need to split 30. Now, there are 3 different products of numbers that you could multiply together to get 30. Because all of these are factors of 30. 3 and 10 are factors of 30. 5 and 6 are factors of 30. 15 and 2 are factors of 30. The product that works best in this situation for 30 is 5 times 6. Alright? So 30 is 5 times 6. And if you look at the denominator, we can take out a highest common factor of what? What is common between these 2 terms? It is 5. Okay, this 5 here is common, so we take it out. Then what's left on the left? 5 to the power x. What's left on the right? 6. Okay, but again, we cancel what's common because simplification through cancellation after factorization is what we can do. Simplification through cancellation after factorization. Simplification through cancellation after factorization. As long as it is not across an addition or a subtraction sign is possible. By factorizing, we've taken 3 terms and made it 1 term. By factorizing the denominator, we've taken 2 terms and made it 1 term. That's what allows cancellation to happen. We can cancel 5 to the power x plus 6 as a bracket with this one. What gets left behind in the numerator? 5 to the power x minus 1. What gets left behind in the denominator? 5. This is our final answer. Can we simplify further? No. No, we can't. This is the simplified answer, and we leave it like this. Can you cancel this 5 and this 5? No. We do not cancel across a subtraction sign. So you can't cancel this and that across. No, you can't, guys. You leave this answer as you see it in this situation. Okay, a very important example, one that requires quadratic trinomial factorization in the numerator, because we can see that for the base 5, the variable has a coefficient that is 2 times the other one. That means quadratic. So we factorize using quadratic trinomial factorization. In the denominator, there are 2 terms. Here in this situation, after splitting this, 30 can also be split to 5 times 6. We can take out a highest common factor. After factorizing the numerator and the denominator, what happens? We have 1 term in the numerator and 1 term in the denominator. Now we can cancel what is common. We cancel the common brackets because cancellation is possible after factorization, and it yields 1 term in the numerator, 1 term in the denominator, which then allows us to write our answer simplified. Okay, so guys, I don't know if there are any questions specific. Further appreciate this idea of factorization. Now look at this one. Very interesting problem, this one. 4 to the power x minus 1 over 2 to the power x plus 1. Once again, if you look at the numerator, how many terms? 2 terms. If you look at the denominator, how many terms? 1 term. In the numerator, we can take that first term, rewrite 4, and it becomes 2 to the power 2 raised to the power x minus 1 over 2 to the power x plus 1. Step number 1 is, in the 2 terms, the only thing we can really do with the first term is change it to 2 to the power 2 raised to the power x. Then we can say 2 to the power x over 2 to the power x. If you look at the numerator, there is a factorization that we can apply, which we call what? There's a type of factorization that we can apply here, because 2 to the power x squared is what we call a PS. In other words, it's a perfect square. 1 is what we call a PS. In other words, it's a perfect square. In between these 2 perfect squares, we have something that we call a minus sign. We refer to that as a difference. So we have a difference of 2 perfect squares, which can be factorized. So we are going to apply what I call difference of 2 square factorization. How many 2 to the power x's do we have here? We have 2 of them. That's a perfect square, and 1 is also a perfect square. So I'm going to, in the numerator, apply that factorization. I open 2 brackets. There are 2 to the power x's, so I'm going to say 2 to the power x times another 2 to the power x. Remember, guys, when you are multiplying same bases, you keep the base, you add the exponent. So when I say x plus x, I get that 2x back. Okay, I get that 2x in the exponent back. 1 times 1 Then you know most of the difference of two squares, you put a plus here, a minus there. Okay, I teach all grades, grade 8 to 12 in high school. There's no grade that I don't teach. Over 2 to the power x plus 1. Now I'm going to put that in brackets because I can clearly see that there is a 2 to the power x plus 1. In the numerator, what do I have now? Initially I had 2 terms, but now I have 1 term. In the denominator, I have 2 terms, but when I put the bracket around my 2 to the power x plus 1, that makes it 1 term. Now, do you think simplification by cancellation will be possible? Most definitely. Simplification by cancellation is going to be possible because I can cancel 2 to the power x plus 1 and 2 to the power x plus 1. So I do that. That leaves me with 1 and 1 in the denominator. So my final answer in the numerator, I have 2 to the power x minus 1 over 1, which is basically 2 to the power x minus 1 as my final answer. Kombi zikalala, why exchange the exponent? Because in mathematics we learn that grade 8, when we multiply two things, we say that multiplication is commutative. The order in which you place things that are multiplied does not matter. X times 2 and 2 times x gives me the same answer. So you are asking me, why do I exchange the exponent to? Because that's what helps me see that, oh, this is 2 to the power x squared. Therefore, this here is a perfect square. That's what enforces it in my head that, oh, this is a perfect square because it's 2 to the power x squared. So I do that just for my mind, all right? But it doesn't really matter. If you decide to write it as 2 to the power 2 or raised to the power x, if you can see that that is a perfect square, that's fine, my dear. You don't have to exchange the x and the 2. I just do it because mentally it helps me to realize that this is a perfect square, because it is a base raised to an even exponent. Any base raised to an even exponent is what we refer to as a perfect square. Okay? So the order doesn't matter. I hope you are answered. Kombi zikalala. No Rams G. You wouldn't be wrong if you used the K method, as long as you remember that at the end you must substitute back. So if you decide to let k be equal to 2 to the power x, then you say k squared minus 1 over k plus 1. Of course, you are going to factorize this, right? Over k plus 1. Then you cancel, right? Then you write your answer k minus 1. Just don't forget at the end that you let k be 2 to the power x. Don't forget now to write your answer in terms of x, because if you fail to write your answer back in terms of the base 2 raised to the power x, that's where you are going to lose your marks. So you can use the k method, right, for the purpose of the simplification step. I don't have a problem with that. Go ahead, my dear. Have a blast of a time. Okay? Just don't forget to substitute back. Okay? Guys, that's it for today. That's it for today. Thank you so much for joining the live for grade 11. It was amazing. You guys were great sports. I would advise you to go to your textbook, go and find problems with simplification. Remember, first, we started today by looking at simplification by where there's multiplication and division alone. All right? And we looked at the steps. there was a way to deal with multiplication and division alone where there is no addition and subtraction between the bases. I'm giving you an orange, I'm saying eat. No, so I'm giving you an apple, I'm saying eat the apple. You know how to eat the apple. You simply grab the apple, you take a bite, and you have a blast of a time. That is the problems of multiplication and division. There is a way in which we do these problems, right? We looked at 3 examples. Example 1, we looked at example 2 and example 3, and we consistently applied the method of changing composite base to prime bases, applying law number 3, applying law number 2 and 1, adding and subtracting like terms, and simplifying using values. Then we turned our attention to addition and subtraction between bases. There's still multiply and divide, but there's an infusion of addition and subtraction. What do we do in those situations? Now we are no longer eating an apple, we are eating a orange. So when you eat an orange, guys, you first must take the peel. You must peel off, something. Don't just all right? There is a way. Factorization plays a role, but we must be able to see what is in our expression in the numerator to see the type of factorization that is to be applied. In our first example, we could see clearly that highest common factor factorization is what we apply, so that we have one term in the numerator and the denominator, then we cancel. In our second type of an example, in our second type of example, we had 3 terms, and in those 3 terms, we could see that because of the situation of these terms and the quadratic trinomial we have to apply quadratic trinomial factorization, which means opening 2 brackets and factorizing. So the K method can assist us in that, and we can be able to factorize the top and factorize the bottom. Are we together? Because we are busy eating an orange. Now we have to peel back. We can't just so I hope you understand that. So type 2. Then we just now did another one where we had to apply difference of 2 squares factorization, because the situation requires us to apply difference of 2 squares factorization in the numerator because of what we see. So it's important that when you look at a problem, observe what is there and then apply the appropriate method when it is required. So guys, thank you so much. I really appreciated you joining the live. Thank you for those that stayed the whole way through from the beginning to the end. Thank you to those that commented. Thank you so much. I really appreciated, for instance, the KCF method that people were talking about in the comment section. Those who spoke about that happiness, you guys were really helpful with that. Your comments are really valued. Thank you for the gifts as well. Those who sent heart meals, those who sent roses, I really appreciate that. Much appreciated, guys. Thank you for the follows. Thank you for the likes. We were able to finish up this session with 45k likes. Very helpful to me as well, and it encourages me. So guys, please, I will like I said, upload this video, this live lesson, onto my YouTube channel. The link for the YouTube channel is in my bio. Maths is a game. You can please go and subscribe there, and then when I finally upload the lesson, I will save it there as multiplication and division, 11 exponents and surds, multiplication and division versus addition and subtraction. You can go and rewatch it at your own time. And if you missed something because of network and don't be faith, then you can actually catch up on that. I'll be going live again in the evening for the grade 12s. We'll be concluding sequence and series with the grade 12s, looking at more exam type questions. I'm also still working on uploading the grade 12 lesson that I did last night, so yeah. And then we'll take it from there. So the last bit of sequence and series before we jump into inverse functions, which is the next topic for grade 12s. Okay, so grade 12s, I always see you in the evening, guys, 9 p.m. From 9 p.m. onwards. If I don't join or start the live at 9 p.m., wait for me to join somewhere after 9, guys, because sometimes my home environment doesn't really allow. And I appreciate the support, guys. When you can gift, please do gift. It's really appreciated. It really like makes it a situation worthwhile, makes it me be able to actually continue providing the service that I provide for you guys. Yeah. So thank you so much. Have a great one, and I'll see you grade 12 specifically later on this evening after 9. Thank you. Sean, don't be free. Cheers.